How do you handle circular dependencies in JavaScript modules? Imagine you are building a web app with multiple JavaScript modules that need to talk to each other. Sometimes, two modules depend on each other directly or indirectly. This creates a loop called a circular dependency. It can cause problems like modules being only partly loaded or getting undefined values during startup. Modern JavaScript, especially with the S6 modules or ECMAScript modules, handles circular dependencies better than older methods. When a module imports another, it gets a live reference to the exported value. This means if the value changes later, the import reflects that change. But this doesn't mean circular dependencies are always safe. If you try to access a value before it is fully initialized, you might get undefined. To manage these circular dependencies well, you should first understand that S6 modules support live bindings. If two modules import each other, the references update as the modules load. However, if the code depends on values being ready immediately, problems can still happen. For example, defining functions at the top level that depend on circular imports without delaying their execution can cause issues. One effective way to handle circular dependencies is dependency injection. Instead of modules directly importing each other, you pass dependencies as parameters. This approach reduces tight coupling and breaks the loop. For example, one module could export a function that takes another module as an argument. Then, in a main file, you connect these modules by passing the dependencies explicitly. Another method is lazy loading or dynamic importing. Instead of importing modules at the top of your files, you can import them inside functions when needed. This delays the loading until the function runs, avoiding immediate circular references. For example, using the dynamic import function inside a function allows the module to load only when required, ensuring it is fully initialized. Refactoring your code to avoid circular dependencies is often the best solution. Look for ways to restructure your modules so they depend only in one direction. You can create new utility modules that hold shared logic or data. Avoid barrel files that import multiple modules and cause circular references. In some frameworks like NestJS, there are features like forward referencing. These let you declare dependencies that are resolved at runtime, not during initial load. This technique helps to avoid startup errors caused by circular dependencies. Sometimes, circular dependencies are unavoidable, especially in complex data structures like trees. In these cases, S6 modules are designed to handle such situations if you structure your code carefully. For example, avoid executing dependent code immediately at the top level. Instead, run code inside functions after modules are loaded. The key is to keep your architecture simple and clear. Use dependency injection and lazy loading to break cycles. When circular dependencies do happen, relying on S6's live bindings and deferred execution to make sure everything loads correctly. This way, your code stays clean, maintainable, and less prone to errors. Mastering these techniques helps you write robust JavaScript modules that work smoothly in modern web development.